Hey guys, Mr. Mackey here. Now yesterday we went over differentiation and how we could find the gradient of the equations once we differentiated them when we have the coordinates. And I set you a challenge to create two equations of lines where one of them is parallel and one of them is perpendicular to this one. So what we need to do firstly is we need to find the gradient by differentiating this equation. So let's do it. So the differential of this equation, so you put dy over dx equals 12x squared plus 4x plus 1 minus 3x to the power of negative 2. That's this equation differentiated. So now we substitute our x value, which in this case is 1, into this equation. So I'm going to write this down here, dy over dx equals 12 brackets 1 squared plus 4 brackets 1 plus 1 minus 3 times 1 to the power of negative 2. So 12 times 1 squared is just 12, 4 times 1 is 4, plus 1, and 3 times 1 is negative, so that becomes negative 3. 12 to 4 is 16, add 1 is 17, minus 3. The gradient of this equation is 14. So now that we know the gradient, we can now start creating our equations of lines. Now, to find a line that's parallel to this one, the gradient has to be the same. So the gradient in this case is 14. So for a parallel, we can use any y-intercept. I'm losing my spelling today. Parallel. There we go. We got there, guys. It doesn't matter what we have as a y-intercept as long as our gradient is 14. So I'm going to do y equals 14x plus 12. That will be parallel because our gradient's the same. However, when it's perpendicular, the gradient, when multiplied with our original gradient, will get us negative 1. So the gradient for this one would be negative 1 over 14. So it doesn't matter what our y-intercept is, so y equals negative 1 over 14x plus 6. And that's the answer. It doesn't matter which equations you chose, as long as the parallel one you have the gradient 14 and the perpendicular you have the gradient as negative 1 over 14, then you're fine. Now we're going to be moving away from differentiation for the last 2 days, and we're going to be focusing on the complete opposite of differentiation. What if we have a differentiated equation and we want to turn it back to the original? What do? Well, this process is called integration. Now, integration is the process of transforming a differentiated equation back to the original. So how we find the equation of a y coordinate. So I have a differentiated equation, dy over dx equals 3x squared plus 2x plus 1. So this is how we integrate. Let's look at the first part, the 3x squared. The first thing we do is we add 1 to our indice. So I'm going to put y equals, and I'm going to put the x, and I'm going to add 1 to the indice, which in this case is 2, so we add it, so it becomes 3. So it becomes x to the power of 3. Because remember, when you do the other one, differentiation, you go down by 1, don't you? So it's the opposite. Then what we do is we divide the number in front of our x, our coefficient, by our new indice. So we divide our 3, which is the coefficient of the x, by 3, because that is what the new indice is. And 3 divided by 3 is, well, 1. Let's look at this one now. So we do 2x. Well, the first thing we need to do is we turn that indice, we add 1 to it. So it's originally x to the power of 1. When we add another 1 to it, it becomes x to the power of 2. We divide that 2, which is the coefficient, by the 2, which is the new indice. So that becomes 1x squared. Now this one's a bit interesting, our plus 1, because there's no x in front of it. That's the same as 1x to the power of 0. So right here, it's exactly the same thing. So what we do is we add 1 to that, so it actually becomes x to the power of 1, because we're adding 1 to that 0, and then we divide our coefficient, which is 1, by our 1, which is the new indices, so it just becomes 1 as well. Now, because there's 1s in front of all of these, they don't really need to be there. So the actual differentiated version is x to the power of 3 plus x to the power of 2 plus x. But we are missing something. When we differentiated equations, what if we had just a normal number like 6? It disappears, doesn't it? It becomes, well, nothing, it becomes 0. There could have been a number in our original equation when differentiating that's just disappeared. How can we find it? Well, we can't. But we need to take into account that there could have been a number here. So we just write a form of algebra. So instead we just write plus c. This plus c means that there could have been a number originally that when differentiated it disappeared. But we don't know what it is. So that's what c means. And that's how you integrate an equation. It's simply reversing the process. Instead of subtracting an indice, you add the indice. Instead of multiplying the indice with the coefficient, you divide the indice and the coefficient. And you add a c at the end. And that's how you integrate. Now let's integrate this equation. 4x to the power of 3 plus 5x to the power of 2 plus 6x to the power of 1 and negative x to the power of negative 2. So when we integrate this one, we have our x, and we do it to the power of 4 because we're adding 1, and then we divide our coefficient 4 by the new indice 4, so that becomes 1. The next one, we have our x, and we add 1 to our indice, so it becomes to the power of 3. Then we divide our 5, which is the coefficient, by the new indice, so that becomes 5 over 3x cubed. Power 3. The 6x, we do our plus, and then we do x to the power of 2, because that's the indice, and we divide our 6, which is the coefficient, by the 2, which is the indice, so that becomes 3. Then for the final one, our x becomes to the power of negative 1, and we divide our coefficient, which in this case is negative 1, by negative 1, so it becomes plus 1x. So let's tidy this up a bit. So it becomes x to the power of 4, because we don't need to include that 1, plus 5 over 3x to the power of 3, plus 3x to the power of 2, plus x to the power of negative 1, and then at the end you just write plus c. And that is how you integrate equations. I didn't want to do many of these because if you understand how to differentiate, then you'd understand how to do the opposite in integration. So I'm going to give you your challenge now. Your challenge is simple. Integrate this equation. Remember what I told you. You add 1 to the indice and then you divide that indice by the coefficient. See what you get. Good luck with it. I'm looking forward to seeing how you do. Let's bring on the final episode of Algebra Week and I'll tell you the new topic tomorrow. Good luck, take care, see you later guys.